Hello students and welcome back to Rankplus JEE English. On last Thursday, I taught you some of the GOC, right? We learned about all the effects that are used in GOC, how to apply it in various applications. Because remember one thing, your JEE Mains paper or be it your JEE Advanced paper, it is only based on application part, right? If you do not know how to apply these effects, then it's better than it is as good as not knowing about these effects, right? So I discussed all the 4 effects with you, all the electronic effects with you, which were inductive effect, mesomeric effect, and your resonance effect, right? And your electromeric effect. So we discussed all those effects. Hello Bacha, hello Praveen, hello Janaki, and welcome to this session. Now in this session is going to be part 2 of GOC. GOC once again is a very huge topic in it, and my method of teaching GOC is like I have to include all kinds of questions that have been asked in your JEE Mains or JEE Advanced exam. Because remember one thing, your older JEE Advanced questions are as it is repeated in your JEE Mains. So it is very much essential that you should know that previously, like 5 years, 6 years, 7 years ago, what kind of questions were asked in your JEE Advanced exam. So again, I've prepared this lecture according to that. This is going to be very, very fruitful for you guys. Once again, welcoming all my lovely students to Rankplus JEE English. My name is Durgesh Ma'am. I'm your organic chemistry educator on this channel and have been an organic chemistry educator from the past 3 years, right? So once again, welcome to the class. Speak louder. I think I should be clear. Can everyone hear me clearly? Can everyone hear me clearly? Let me know. Chaliye. So in this session, we're going to start with the isomerism. We're going to start with the structural isomerism, and then we're going to move on to the geometrical isomerism. So we're going to complete at least these 2 isomerism in this series, and in the GOC part 3 there's going to be a part 3 because we are again left with aromaticity. It is a very huge topic. Aromaticity, I'm going to cover it in the last part of GOC, all the applications of aromaticity, and a plethora of questions are asked from that topic, right? So let us understand. Hello and speak louder. I think I'm audible. Can everyone let me know in the chat if I'm audible, or is it just with Jayvant that is having the problem, right? It is a huge chapter, absolutely huge chapter, right? See, somebody who claims to finish GOC within 2 hours is bluffing you, right? He's making a fool out of you, because if you complete this chapter for JEE especially, you cannot do that. You can get summary notes, mind maps for 2 hours, but not the entire chapter. And this is going to be a ride. You're going to love isomerism after I've taught you. So let us begin. Audible, audible, perfect, perfect, perfect. So let us start with the very first thing. What is isomerism, right? Remember one thing. Isomerism or isomers means what? Isomers are those compounds, okay? What are isomers? Isomers are those compounds which have same molecular formula. What do they have? They have same molecular formula, but where are they differing? They differ where? They have different structures, right? So this is the definition of isomerism, which means they have the same formula, molecular formula. I taught you the molecular formulas of so many things, right? I've taught you the molecular formulas, audible, audible, perfect, perfect. Okay? Now isomers are those which have the same molecular formula. For example, if I've written CN H2N plus 2O, right? This is a general formula of which functional group? Who can tell me? This is the general formula of which functional group? Can anyone answer me? Which functional group's general formula is this? This belongs to 2 functional groups. One is alcohol, and the other one is ether. I will prove it to you how. For example, if I've written C3 and 3 into 2 is 6, C3H6, and I've written O, right? So what kind of formula can I form with it? I can write an alcohol with it like CH3CH2OH, and I can as well write a ether with it like CH3OCH3. Can everyone see that? With the same general formula, I've written alcohol and ether. Can everyone see that the molecular formula is same for both these compounds, but their structure is different, hence they are isomers. Simple, understood? Now we are going to classify these isomers into two categories, two big categories. One is structural isomer, the other one is stereoisomers. What is a structural isomer? Where the connectivity is changing. Can everyone see? Here the oxygen is connected to just one carbon, while in the other compound, the oxygen is connected to two carbons. Can everyone see? The connectivity is changing. Hence, these are structural isomers, where the connection, where the connectivity with the carbons, with the atom changes is a structural isomer. And what are stereo? When the spatial arrangement is changing, right? Stereoisomers are those where the arrangement of atoms in space changes. And what is meant by that? We're going to figure out soon in this lecture. Do not worry. Now, once again, structural isomers are of all these types: chain isomers, position, functional, metamerism, ring chain, tautomerism. All of these kind we're going to study in this lecture one by one. And what kind of questions are asked? Some very beautiful questions are asked, especially from your metamerism, especially from your tautomerism. I'm going to teach you everything about them. So please stay tuned on this session. It's going to be very, very fruitful for you guys, right? Now the next thing is stereoisomerism, right? And once again, remember one more thing from my side. As they've reduced the syllabus, last year what happened? That was the first time or the second time that the syllabus was reduced so much, right? Last time if we talk about. So the paper was comparatively easy, and because the paper was so easy, we were seeing such a high cutoff, right? We saw such a high cutoff. But this year, I do not think the paper is going to be that easy. It's going to follow the previous JEE Main's trend, where the paper used to be difficult. Chemistry, especially organic part, was not easy to do. This year, it was pretty easy. It was like you can just look at the question and just tick mark on the correct answer. But before that, the papers used to have questions where you have to apply your brain. You have to apply all the chemistry that you've read in class 11th, right? Class 11, especially the GOC part. So that's how we're going to prepare for your JEE 2025 exam. So once again, stereoisomers are once again of three types actually, right? One more type, which is your conformational isomer. What it is called? It is called your conformational isomer, right? Very, very important. Conformational isomers. God of chemistry. Yes, I think I agree with Dharneshwaran in this sense. It is actually the god of chemistry. If you know GOC, then you can actually very much do the other parts of your organic chemistry. Perfect analysis, Dharneshwaran. Chaliye. So let us just resume here. So what did I teach you? That stereoisomers are again divided into three kinds, which are optical, geometrical and conformational. Remember one thing, your optical and geometrical isomers, you can separate both these isomers. These are separable. These are separable isomers that you can separate through physical or chemical means. But your conformational isomers are actually non-separable. Very, very important. You cannot separate it. These are non-separable. Okay? That you can never separate them through any physical or chemical means. Understood? But these two you can separate by chemical means or whatever. So right now we're going to delve into our first kind of isomerism, which is structural. Very, very easy. So before I get into its structural isomer, there is some points that you should remember. Number first is, isomers are molecules that have the same molecular formula. I've already taught you this. What is the definition of isomer? It's written over here. Next is, that excludes any different arrangements which are simply due to the molecule rotating. Remember one thing. What happens especially when you consider a single bond? For example, I've made a single bond like this. So what happens around a single bond? Around a single bond, your atoms can rotate. Remember this thing. Your atoms, your groups, your molecules can actually rotate around a single bond. right? This can actually rotate and it can form a molecule like this, right? And this can once again rotate. So these two are actually called conformers of each other. These are not isomers, these are conformers of each other. How do you prepare isomers? For preparing isomers, right? So this will not be considered as an isomer. That's what they have said, that if the atom is rotating, it is able to rotate, it is not an isomer. Next is, in structural isomerism, the atoms are arranged in a completely different order. I've already taught you that. Now let us delve into the first kind, which is the chain isomerism. What is chain isomerism? Look at the example over here. I have taken normal pentane molecule over here. Everybody can see normal pentane molecule, right? This is arranged in a straight chain. Now what if I keep on reducing the length of the chain and adding branches, right? Now the length of the straight chain is of 4 carbons and there is 1 branch. Now what did I do in the next? I reduced the length even further and added 2 branches over here. Can everyone see these 2 branches? Right? Now what I'm doing, I'm reducing the length of the chain. So these are called chain isomers, where you are reducing or increasing the length of the chain and adding on branches on it. Now in all these 3 isomers, these are N-pentane, right? These are pentane isomers. So all of these have the same molecular formula, which is C5H12. You can count. All of them have 5 carbons as well as 12 hydrogens. You can count, and this would be the molecular formula. Simple. So these are your chain isomers. Now what is the thing that you should know for your JEE exams for the chain isomerism? The number one thing, as the chain length decreases, as the branching increases, write it down. As branching increases, can everyone see when I'm moving from here to here, the branching is increasing. So in this case, what is happening? Can everyone see, as the branching is increasing, the molecule is actually getting a spherical structure, right? Actually getting into a spherical structure, and we all know that spherical structures have the least surface area. Hence, as the branching increases, the boiling point actually decreases. This is a very, very important relationship. Boiling point actually depends on lots of factors. I discussed it in my first GOC lecture as well. You should definitely go through that. It's a perfect lecture for your first GOC class, right? Now we have entered our second GOC class. Now, bacha, as the branching is, can you see, this is the most branched molecule, right? So this will have the least boiling point, because as the branching increases, the actually surface area is decreasing. Hence, the stronger forces are decreasing over here, okay? And therefore, the boiling point actually decreases. Understood? Yes. Parent chain is different. Absolutely, absolutely. Shall we move forward? Now, there is one question from your, okay, just make it JEE 2024. I'm really sorry. Just make it JEE 2024. This is from your JEE 2024 question. Look at this question. Statement 1. The boiling point of 3 isomeric pentanes follows the order. They have mentioned 3 isomeric pentanes. Do they follow the same order for boiling point? Is this statement true or is this statement false? Number first question. And in the statement 2, they have given the reason for that as well. So this is absolutely correct order, because as the chain length increases, boiling point increases, right? So this is absolutely true. Normal pentane has the highest boiling point, followed by isopentane, followed by neopentane, right? So this one is actually called neopentane. This one is actually called neopentane. This one is actually called isopentane, right? This one is actually called isopentane. Okay, understood? Let's move forward. Okay, this first statement is true. Let us look at the second statement. When branching increases, the molecule attains a shape of a sphere. Yes, that is true. This results in smaller surface area of contact. Absolutely true. Due to which intermolecular forces are weak. Absolutely true. Hence lowering the boiling point. True statement. This is the exact reason I gave you. See, this is the exact p-value that they have asked. Right? Both A and R true. Absolutely, Dharneshwaran. Absolutely true. Now let's move on to the next. Next is ring chain isomerism. So the ring chain isomerism is shown by, maximum cases it is shown by an alkene and a cycloalkane. Why is that the case? Okay, let me write down the molecular formula of an alkene. What is the general formula of an alkene? It is actually CnH2n, right? Now remember one thing, this general formula is followed by both alkene as well as cycloalkane. Very, very important, right? With the same general formula, I can either form an alkene or a cycloalkane. Now look at this alkene over here. This has 3 carbons. This cyclopropane also has 3 carbons. This alkene has 3, 4, 5, 6 hydrogens. Count the number of hydrogens on this cyclopropane. 1, 2, 3, 4, 5, 6. 6 hydrogens are present on the cyclopropane as well. So these two actually show what kind of isomerism? Ring chain. So ring chain isomerism is shown by alkene as well as cycloalkane. Easy? Let's move forward. Next kind of isomerism is position. Position isomerism is actually shown by the molecules which contain a functional group, right? Any functional group, it can either be a double bond, can be a triple bond, or can be any functional group like OH functional group, right? Now look at over here. Now here can you see the OH is actually present on the second carbon, and similarly here in butane 1-ol, the OH is present on the first carbon, only the position of the functional group is changing. The entire chain remains the same. Can everyone see? The chain length is same. The chain is there, they have a straight chain. Only the position of the functional group is changing, hence they are position isomers. Understood? Now look at the next option. The next example. In the next example, can you see it is pent 2-ine, which means at the second position they have a triple bond. In the next example, they have a pent 1-ine. Once again, the position of the triple bond is changing, the rest of the molecule remains same. Hence, they are position isomers. Easy? Easy? What are the main topics? Beta, everything is main. In GOC, I cannot tell you these are the main topics and skip the rest of them. No. Whatever topics I'm teaching you are absolutely necessary to know. You have, like, there have been questions asked from each and every topic. Hence, you need to know each and every topic in detail. Whenever we are going to do the other chapters, right, there I can tell you that most of the questions are asked from this topic, from that topic, right. There we can make a distinction, but here in GOC, you cannot afford to skip a thing, right. So we are just going to take 3 GOC classes and we are going to get over with it. And haloalkanes and haloarenes have already been done on this chapter, right, by Nabamita ma'am. You should definitely watch that. GOC part 1 has also been done. Definitely watch that and then come back to this video. Okay? Now I'm going to do another example of position isomers. Are these examples clear for position isomers? Shall we move on to the next ones? Right? Clear? Perfect. Next is bacha. Okay, look at these molecules. What kind of molecular formula do they all have? Can I write their molecular formula as they have, each of them has 6 carbon in the ring as well as a 7 carbon over here. So each of them has 7 carbon followed by 1, 2, 3, 4, 5, 6, 7 hydrogens, right? 7 hydrogens and 1 chlorine, isn't it? Each of them has carbon 7, H7 and 1 chlorine. So each of them has this molecular formula. With this molecular formula, you have made 4 kinds of isomers. Now, what you are doing, all the other things are remaining the same. You are just changing the position of this functional group, which is the chlorine functional group, right? So, what is this showing? They are once again showing you what kind of isomerism? Position isomerism, isn't it? They are once again showing you position isomerism, right? Now, bacha, you should know another thing. When 2 molecules are just closer to each other, they are called orthoisomers. This kind of molecule, when the one atom and the other group are like this is called the meta-isomer. And this kind of molecule, where the 2 groups are exactly opposite to each other, it is called the para-isomer. Very, very important. And what is this position called? What is this position called? I taught you in the last lecture as well. What is this position called? Beta, whenever whenever there is a carbon directly attached to the benzene ring, right? Whenever there is a carbon directly attached to the benzene ring, it is called the benzylic carbon. What kind of carbon it is called? It is called the benzylic carbon. Very, very important. This kind of discussion, this kind of differentiation they do ask in your exams, right? Shall we move forward? Chaliye. Next is once again functional group isomerism. Right now we have done how many kinds of isomerism? We have covered chain isomerism. The next thing was position isomerism. The other thing was ring chain isomerism. This is the fourth kind of isomerism we are studying, which is called the functional group isomerism. So bacha, functional group isomerism is, as the name suggests, is shown by the functional groups. Now what is functional group isomerism? It means that when I write the general formula, for example, I taught you about ethers and alcohol. Both of these functional groups have the same general formula, which is CnH2n plus 2O. With this general formula, you can form an alcohol as well as an ether, right? So these are showing what kind of isomerism? Functional group. Why? Because each of them has same number of carbon atoms, which is 2 carbons, 6 hydrogen, 1 oxygen. This also has 2 carbons, 6 hydrogen and 1 oxygen. But both of them have different functional groups in them. Hence, they are showing functional group isomerism, right? Now look at over here. This is aldehyde and ketones. Aldehyde and ketone follow the general formula CnH2nO, right? CnH2nO. With this general formula, you can form both aldehyde as well as ketones. For example, look at this general formula C3H6O. With this same molecular formula, you can form an aldehyde as well as a ketone. The molecular formula is same, but the functional group is different. Hence, they are showing functional group isomerism. Is this thing clear? Okay. What about physical chemistry? Physical chemistry will be taken by Nabamita ma'am once again, right? I am your organic chemistry educator over here. Chaliye. Okay, next is carboxylic acid and esters. For carboxylic acid and esters, look at the what is the general formula? But a general formula is CnH2nO2. Remember this thing. With this general formula, you can form both acids as well as esters, right? And once again, I want to correct you. There is a place in your NCERT, I am forgetting which exact chapter. It can either be the aldehyde, it has to be the aldehyde ketones chapter, right? In that aldehyde ketones chapter, they have given you this exact molecule. And they have given the wrong name for that, right? In the aldehyde ketones chapter, I think they have given this exact molecule over there. I will correct, I will let you know in one of the, I will definitely post on this channel where the incorrect naming is given. Because remember once again that Supreme Court has given the decision, has taken this decision that no matter what, even if it is written incorrectly in NCERT, what would be considered in your JEE exam or in your NEET exam would be the thing that is actually correct. Because misprinting can happen even in NCERT, that doesn't make the wrong thing right. Understand this thing. Okay? So, bacha, what am I doing? I have taken this general formula. With this general formula, I have formed an acid as well as an ester as well as another ester. Right? How have I done that? I will show you. For example, I have to write C3H6O2. Okay, make it with me even if you're not understanding, right? If you're not understanding, we will draw this molecule together. For example, with this molecular formula, let us draw the acid first. What kind of acid can we draw? We can draw CH3, CH2, C double bond O, OH. See, there is no other possibility of the acid. Because acid is one kind of functional group which has to be at the terminal end. It can either be here or be here. It has to be at the terminal position. It cannot be anywhere in the between. It is just not possible. So this is the only possibility for the acid. Now let us write down what kind of esters can I form. Okay? So for the ester, I will just write down the formula of ester. Isn't this the formula of ester? Right? With this formula, I will just write down one CH3 over here. I've already consumed 2 carbons. I'm left with just one more carbon. So I will write the other carbon over here. So this is one of the ester that I formed. Now to name this ester, what do? You first of all write down the group that is directly attached to the oxygen. So here methyl is attached, so we'll write methyl, and then whatever is left behind, 2 carbon atoms are left behind, so we'll write methyl ethanoate, right? This would be the name. This would be methyl ethanoate. Okay, I have written methyl ethanoate here, methyl ethanoate, this one. Now what else can I do? I'm once again drawing the ester group over here. I've drawn the ester group. Now with this oxygen, what can I do? What can I do? I can attach, now with this oxygen, what can I do? With this oxygen, I can attach CH2, CH3, and here I can add a hydrogen. What I've done? With this oxygen, I've attached both the carbons. Whatever carbons were left behind, I've attached. Now what has happened? Now with the oxygen, what kind of group is attached? Ethyl group is attached, isn't it? Ethyl. And whatever is left behind, just one carbon is left behind, so it will be ethyl methanoate. What it would be? It would be ethyl methanoate. You should definitely know the naming of the ester, because at one point, even in your NCERT, this naming has been done wrongly, right? Chaliye, I hope you're understanding this thing. Structural isomerism, functional group isomerism, right? Functional group is clear. I have told you that there are 3 kinds of functional group, which are alcohols and ethers. Look at over here. Alcohols and ethers, aldehydes and ketones, as well as your acids and esters show functional group isomerism between each other. Understood? Next is, bacha, other kinds, other examples of functional group isomerism. For example, I took the NO2 group. I can write this NO2 group like this. For example, with the carbon, I've attached the nitrogen group directly, right? The other way, what can I do the other way? I can attach oxygen over here, and with the oxygen, I can attach the carbon. Here, once again, the group is NO2 only. Here also it is NO2 group, but the atom that is attached directly to the carbon is changing. When the connection is made via the nitrogen atom, it is called nitroethane. But when the connection is made via the oxygen atom, it is called the ethyl nitride. This is the nitride group. This will become the nitro group. This becomes the nitride group. So these are different functional groups. Understand this thing. Both of them are different functional groups. Now look at the other example. This is also very important. All the 3 kinds of amines, which is primary amine, secondary amine, and tertiary amines, are actually different kinds of functional groups, right? Different kinds of functional groups. Okay, for example, look at over here. What is amine? If I've taken ammonia like this, I've taken ammonia like this, right? This, what is this structure called? This molecule is called ammonia. Now, what if I start replacing the hydrogen of ammonia one by one? When I replace one of the hydrogen, it becomes RNH2, right? This is your primary amine. When I actually replace another hydrogen, for example, I've replaced 2 hydrogens of ammonia, it becomes RNHR, which means it is secondary amine. Now, if I replace all the 3 hydrogens, right? All the 3 hydrogens, then it actually becomes tertiary amine. This is called tertiary amine. Understood this thing? So these are 3 kinds of amines, and these are actually not isomers of each other. These are different functional groups. These are considered as different functional groups. Very, very important, right? For example, secondary amine and primary amine will actually show functional group isomerism. And, okay, understood this thing? Because these are different functional groups. For example, ethyl amine and diethyl amine. What would be their molecular formula? Here the molecular formula will be, here it would be CH3, here it would be CH3, so it would be C2H7N, right? Here it would be carbon CH2 and CH3, so it would be C2H7N here also. So both of them actually have the same molecular formula, but the functional groups are different. Primary and secondary amines are actually different functional groups. Understood? This is a very major distinction which students often get wrong. Now, I want you to write all the functional groups isomer of C3H6O2. Can you just look at the formula and tell me what kind of functional group isomerism would they show? Can you just look at this formula? What kind of general formula is this following? Can everyone tell me that this is actually following CnH2nO2? CnH2nO2 kind of general formula. Isn't it following this kind? Isn't it following this kind? Because this is C3 and the double of carbon there is hydrogen and then 2 oxygen. Now this general formula is actually followed by acids as well as esters. I just taught you, right? This general formula is followed by 2 functional groups, which is acids and esters. So you can form acids and esters out of them. Understood? Acids, yes, they'll show functional group, not positional. Yes, position also. You are absolutely right, Dharneshwaran. They will show both functional as well as position isomers. Absolutely correct. Where they will show position isomers, for example, between these two ethanoid. Right? No. They're actually not showing position isomers. I will actually correct you. What are these showing? These are actually metamers of each other, not position isomers. Why? I will let you know in just some time. Okay, you are correct in some way, Dharneshwaran, that these will actually show function group isomerism, just like them, acids as well as esters. But what am I saying? What am I telling you? That these two, between these two esters, are these two esters positional isomers? No. These two esters are actually metamers. What are metamers? I'm just going to teach you. Okay, that is a distinction that I want all of you to know. So this is once again a homework for you guys. You have to write all the functional group isomers of C3H6O. Right? You have to write the functional group isomers of C3H6O. Right? Now, before I move forward, I want to tell you another thing. So I've already written the functional group isomers of esters and acids on this page. Okay, on this page. But what if I form something like this? What if I make something like this? CH2 double bond CH, and I will write here C double bond OH. Okay, now count the number of carbons here. This has, ma'am, 3 carbons as well as, but this doesn't have the enough number of hydrogens, right? It just has 2, 3, 4 hydrogens. 2, 3, 4 hydrogens. So this won't work, I guess. What if I form an alcohol over here? What if I write it CH and here will be CH2OH. Now it is 1, 3, 4, 5, 6, right? Now this is once again a functional group isomer of this same molecule, isn't it? Of this same molecule. Can I write it like this? This is once again there is a alkene over here and also a alcohol over here. So this is also a kind of functional group isomerism of this, isn't it? Does anyone have any doubt in this? Can I write something like this? Okay? And what if I write something like what if I write something like this? CH3, one second, CH3, C double bond O, CH2OH. Now count the number of carbons as well as the number of oxygens over here. Now count the number of hydrogens, oxygens. Hello everyone. Beta, this is going to be a 3-hour session, right? We're going to extend it till 3 hours at least 3 hours, right? So this is also another kind of functional group. Can everyone see? I can also write, so I've already taught you, the one thing that I've taught you is that with this general formula you can write acid as well as your ester functional groups, right? But you can also form other functional groups. You can also write a ketone along with the alcohol. This is also functional group isomerism once again, right? I can also write it like this. CH2OH and CH2 and I can write C double bond OH. Now count the number of carbons, hydrogens and oxygens. This is once again making sense. I can also write a ketone with the alcohol, a aldehyde with the alcohol. What is the other thing I can do? I can actually like a ether, CH3OCH2, and here I can write a aldehyde over here. So this once again is following the same general formula. So you have to do hit and trials with it. Similarly, what you can do, you can also form a ring like this. You can as well form a ring like this. This is one kind of ring that you can form, 1 carbon, 2 carbon, 3 carbon, right? Another kind of ring is you can also form a ring like this, right? So all of these are also functional group isomers because you've written different functional groups with them, right? Understood? Chaliye. What are the topics that we cover? Please make a flow of live or index. But I've already taught you. I've already told at the beginning of the session that this is going to be the isomer lecture. What we're going to cover here are the structural isomers as well as geometrical isomers. That is it. Because this is a big topic. What I could have done, I could have just given you a list of these things and I could just have completed it within half an hour. But I'm not going to do that. I'm going to teach you this one by one so that you know how to form position isomers, how to form, so that you can differentiate in the difficult questions, right? So let us just move forward now. I've taught you the functional group isomers. Next is the metamerism. Once again, a very, very important topic, metamerism. So what are metamers? In metamers, what you have to keep in mind, there will be a heterofunctional group in the middle somewhere. Okay? For example, ethers show for metamerism. Okay? What is metamerism? For example, around this oxygen, what is happening? The length of this chain will vary. Around this oxygen, the length of this chain is going to vary, right? For example, around this oxygen, there are 2 carbons here, 2 carbons here. And what I've done in the next isomer, around this oxygen, I've just kept 1 CH3 over here and I've written 3 CH3 over here. So I'm changing the length of the alkyl chain around this oxygen atom. So these are called metamers. Once again, metamers is shown by your ester functional group. So what is happening? There is once again oxygen here. Can everyone see? Around this oxygen, what you are doing are changing the length of the alkyl chain. For example, here 2 carbons are there, here 2 carbons are there. In the next thing, what you've done, you've taken 3 carbons over here. So what you are doing is changing the length of the chains around it. Similarly, look at this secondary amine. Around this secondary amine, once again, what you're doing, you're changing the length of the chain around this nitrogen atom. Right? Here, once again, around this nitrogen atom, you're changing the length of the chain. Understood? So, for example, I am any heteroatom. I am someone without a carbon. Hai na? For example, only these compounds will show your metamerism. It can be either an ether, for example, oxygen is there. That's a heteroatom. Hetero means instead of carbon, any other atom is there. Oxygen is there. There is nitrogen is there. Sulfur. This is thioether, this is secondary amine, this is ether, this is your ester functional group. These will show metamerism. Anhydrides, once again, can you see that there is an oxygen in between, right? So this will definitely show metamerism. Anhydrides, once again, your tertiary amines will definitely show your metamerism. And once again, your what? Amides. Can you see once again, nitrogen is there, a heteroatom. So they will definitely show what? They will definitely show your metamerism, right? Beta, that's a good question, bacha. Is functional completed? Yes, functional is completed. Now we have moved on to the metamerism part. That is the only thing that you need to know in functional groups, right? There are 3 major functional group isomerism, that is, as I've taught you that. But instead of that, more than that, I've also taught you that you should definitely know how to make all these formulas. And Dhaneshwaran has asked me, ma'am, how to know how many isomers are there. Then, bacha, you can only find out with hit and trial method. You have to keep on drawing. So the first thing is, they'll never ask you how many isomers are shown by such a functional group which I've shown you. Okay? They'll only ask you in the very, in the very which are very easy to predict and which have a general formula, right, which you can just take out using the general formula. They never do that with students, remember that. I've seen like past 15 years of JEE Mains, JEE Advanced paper, they never do that. So still I'm teaching you because those kinds exist, so you must know about it. Okay? They only ask you very simple questions, and whatever changes they can make in the question paper, I will definitely let you know in this session. Do not worry on that. Okay? What do I mean by this? I want to explain to you once again the metamerism part, because so many students get confused in it. I'm going to ask you confusing questions. So just stay with me. For example, how do you write ether? You write ether like there is a R group here, an alkyl group here, an oxygen here, and another R group over here, right? This is how you write an ether. How do you write a secondary amine? You write a secondary amine, there is a nitrogen over here, a hydrogen over here, and an alkyl group over here, and an alkyl group over here, right? This is how you write a secondary amine. How do you write a tertiary amine? You write a tertiary amine, nitrogen is over here, an alkyl group over here, an alkyl group over here, another alkyl group over here. This is how you write a tertiary amine. How do you write a ester? You write a ester like this, C double bond O and O. Can you see another heteroatom is coming over here? So around this heteroatom, once again an alkyl group is here and an alkyl group is here, right? Once again, how do you write anhydride? Okay, I'll write it over here only. You write anhydride like C double bond O followed by O, C double bond O. So can you see there is once again a heteroatom. Hetero means another atom, an atom other than your carbon. So once again an alkyl group is here, once again an alkyl group is here. Can everyone see that? Right? Now what can I do? I am moving on to other functional groups. For example, your thioether. Your thioether once again has an atom other than carbon. So this will definitely show metamerism, right? And once again your amide. How do you write amides? You write amides like CONH, right? And here some other alkyl group is there, here some other alkyl group is here. So can everyone see that there is a heteroatom present wherever metamerism is shown? Okay? Wherever metamers are shown, there has to be a heteroatom in the chain. If there is no heteroatom, then metamerism is not shown. What do I mean by that? For example, if I write a ketone, C double bond O, I've written 3 carbons over here and 1 carbon over here. And what I've done next, C double bond O, I've written 2 carbons over here and 2 carbons over here. Now if I ask you, do this functional group show metamerism? What is happening? Once again you'll see, yes ma'am, this is a functional group. I've identified the functional group. Around this functional group, the length of the chain is changing, right? Here 3 carbons are there, here 2, and here 1, here 2, right? So length of the chain is changing, hence there are metamers. But this is the wrong answer. That's why I'm teaching you this. This is absolutely wrong. This doesn't happen. Why? Because this carbon is not a heteroatom, not a heteroatom. Hence, it will not show metamerism. Hence, it will not show metamerism. Is this thing clear? Hence, it will not show metamerism. Is this thing clear to everyone? Right? Yes, beta, what is your doubt? I will definitely take your doubts, right? What is your doubt? Ma'am, how to know basics to mains level? Yes, beta, this is definitely from very basics to mains level, right? This is my only goal. That's why I've divided GOC into 3 parts, correct? I will definitely take your doubts. You can send me your doubts once again if you want personal touch, and if you have any question while actually solving JEE Mains, JEE Advanced, PYQs, or whatever questions you have, whatever modules you have, you can contact me on NANDINI, Nandini JEE. This is my personal Telegram channel. You can send me your questions, and I've done this thing with my previous year students as well. Right, and this is a pretty new channel, so you guys must know that this is where I answer all your questions. You can definitely reach out to me on that. Right, chaliye. Optical part is weak. Optical we are going to do in the next session. Right now, optical I'm not doing because your, structural isomerism. I have so many types of questions to show you that you must definitely know. And especially, again, once in your geometrical isomerism, I have once again plethora of questions that are asked. We're going to discuss each and everything in detail. So your stereo will be done in the next session, next GOC part 3, not today. I'm once again reiterating. Understood? Optical part is weak. After watching my lecture, your optical will be the strongest. It's not that hard. I will teach you the tips and tricks that you need to actually make it strong, right? So once again, let's move forward. Understood the metamerism part? So that's what I've taught you in this figure. Can you see this diagram over here? Here once again, this is pentane 2-one, this is pentane 3-one. One might think, what most students do? Yes, ma'am, around this functional group, the alkyl chain is changing, the length of the alkyl chain, hence these are metamers. No. What is it then? What is happening? For example, here the functional group is at the second position. Can everyone see that? Here your functional group is 1, 2, 3 at the third position, pentane 3-one. So what is happening? The position of the functional group is changing. Hence, these are position isomers. Is this thing clear? Once again, look at the question over here. What is this question? Once again, there is a pentane 2-one over here I've drawn. And look at the question over here. Here it is what kind? This is once again butane 2-one, 3-methylbutane 2-one. So the position of the functional group is same. Can everyone see? Here the position of the functional group remains the same. So what is changing? You cannot say ki ma'am these are functional group isomers. Why? These are position isomers. Why? Because the position of the functional group is same. So what are they? These are actually chain isomers. Why? Because the chain here is a straight chain and here the chain is becoming branched. So these are actually chain isomers. Understood this thing? Understood the difference between position, metamers as well as your chain isomers. Is this thing clear to everyone? Okay? It is not a metamer. That's what I'm teaching you. It is not a metamer. That's what I'm teaching you. Keep this in mind. If you still have any doubts, you can definitely ask me if you're watching this lecture live. Right? Definitely ask me. It is not a metamer. Ankit Singh, is this thing clear? Clear, Meenu? Hi, Null. Okay? Clear, everyone? Okay. Understood? If you still have any doubt, ask me because I'm going to ask you many questions now, right? Now, with so many questions, we're going to make things more clear. So, what I've done over here, I have given you 1, 2, 3, 4. 4 kinds of molecules over here. Now, my question to you is, what kind of isomerism is shown by these 4? For example, what kind of isomerism is shown by 1 and 2? Similarly, let's not write and like this. What kind of isomerism is shown by 1 and 2, 1 and 3, as well as 1 and 4, right? Sometimes I forget how to write and. Seriously, I forget. Like, how do you write and? Like this, right? No, like this. Okay. I think I have dyslexia. You know what is dyslexia? Have you seen Tare Zameen Par? What that child has? I think I have that. 1 and 3 and 1 and 4, right? Yes. So what kind of isomerism is shown between these molecules? Can anyone write in the chat box? 1 and 2 shows functional group isomerism. Absolutely beautiful answer. Actually, 1 and 2, 1 and 3, 1 and 4, all of these. Why? Because this is an alcohol. All of these are ethers. So 1 and 2, 1 and 3, 1 and 4, all of them actually show functional group isomerism. Beautiful answer, right? Now I'm going to ask you what kind of isomerism is shown by 2 and 3. What kind of isomerism is shown by 2 and 3? 2 and 3, what kind of isomerism? 2 and 3, what kind of isomerism is shown? Answer. Yes, Ankit Singh, absolutely. How do we differentiate? Ankit Singh has asked me. Ankit Singh, that's what I taught you just previously, right? How do you differentiate between metamers, position and chain isomer? See, Ankit, if you still have doubt, ask me. I will once again repeat because I've gotten the clearance from other students. Okay? Position isomers, 2 and 3 are position isomers. No, that's what I taught you. See here. Here what is happening? Oxygen is here. Oxygen is a heteroatom. Hetero means it is something other than carbon. So whenever the alkyl chain is changing around something other than the carbon, which means around the heteroatom, then it is actually called your metamers. Can you see the length of the chain is changing? So 2 and 3 are actually metamers. Metamers, that's what I taught you just 5 minutes back, right? Not even 2 minutes ago, right? So these are actually metamers. Why? Because the length of the chain around the heteroatom is changing. Here around the heteroatom, 2 atoms are there. Here around the oxygen, there is just 1, 2, 3 atoms are here and 1 atom is here, right? And similarly, what is happening with 2 and 4? What kind of isomerism is shown by 2 and 4? What kind of isomerism is shown? 2 and 4. What kind of isomerism? Answer once again. Got it, Ankit? Perfect. Hi, ma'am. I'm studying class 12th, but I'm not confident about my topics of maths, physics, chemistry. Can I crack JEE? If I start now within 60 days, can I crack? Beta, for the chemistry part, I can definitely say that you can definitely crack because chemistry is pretty easy. Pretty easy in the sense it is predictable, and that's what we have started our 60-day series crash course over here. So if you are watching us, then you will definitely complete. But with maths and physics, I cannot guarantee because those are the subjects which require lots and lots of practice. With chemistry, I can definitely guarantee it is pretty easy to actually score actually full marks in JEE Mains, not JEE Advanced, right? Chain isomerism, Null has answered chain and Dharneshwaran has once again answered chain. Okay, 2 and 4. Beta, in 2 and 4, what is happening? Can everyone see that the chain length is actually changing? Can everyone see the chain length is actually changing? Right? The chain length is changing around the heteroatom. These are once again metamers only. Metamers only. The chain length is changing around the heteroatom. Right? The chain length is changing. Therefore, these are metamers. Right? And 3 and 4. Between 3 and 4, what is happening? So that's what, koi baat nahi. Even if you are making a mistake over here, but right now just understand, whenever the chain length is changing around the heteroatom, they will definitely be metamers. No other possibility is there, right? But whenever there is no heteroatom present, in that case we see, is it a chain isomer, is it a position isomer, right? Here it is metamer, no matter what. But if I ask you to compare third and fourth, what is happening with third and fourth? What is happening with third and fourth? What is happening with third and fourth? This is a very interesting question once again. This has taken an extremely interesting turn now. What is happening with third and fourth? What kind of isomerism are they showing? Can you see that in third, the methoxy group, this is the methoxy group, right? Here, the chain length, if I compare the chain length between third and fourth, then here also one carbon is there. And here also one carbon is there. So I cannot say that they are metamers because the chain length on one side is exactly the same. So they are not metamers. Then what are they? So bacha, now remember, how do you actually write the IUPAC name of ethers? How do you write? For example, this is taken as the first carbon, second carbon, third carbon. So you write its name that at the first position, there is a methoxy group. This OMe group on whole is called the methoxy group. And methoxy is present at the first position. So you write down 1 methoxy propane. How do you write the name of this? Here what happens, you consider this as the main chain, right? Now at the second position, there is the methoxy group present. So you write down 2 methoxy propane. Okay? Everything is hidden in its IUPAC naming. That's why having IUPAC name by heart is very, very essential no matter what you're doing. So here can you see that the methoxy group is at the first position. Here the methoxy group is at the second position. So the position of the functional group is changing. Hence these are position isomers, isn't it? These are position isomers. Very, very important. Is this thing clear? Now got it? Now got it, everyone? Everyone, ठीक है? This are null has already answered position. Absolutely beautiful answer, beautiful answer. Now let us, is this example clear? So I'll move on to the next example. The next example is here in front of you guys. Once again, there are 1, 2, 3, 4 molecules in front of you. I've also given IUPAC naming so that things are easier to guess for you guys, even if you lack in IUPAC naming. But this is the one thing that you should definitely make strong, right? Now I'm going to ask you, what is the relationship between 1 and 2, 1 and 3, as well as 1 and 4 molecules? What is the relationship between 1 and 2, 1 and 3, 1 and 4 molecules? What is the... Ankit Singh is saying I was taught wrong. Yes, most of the kids were taught wrong, Ankit. I completely understand, completely. Right, so that is why you should definitely check this thing out. This session is very important. Okay, chaliye. 1 and 2 are functional group. So Ankit Singh is really fast. 1 and 2 functional group, absolutely. Actually 1 and 2, 1 and 3, 1 and 4. All of them are functional group isomers. What kind of isomers are there? Functional group. Why? Because here aldehyde group is present. In all these 3, keto group is present. So these are functional group, absolutely. What is the relationship between 2 and 3 isomers? What is the relationship between 2 and 3 molecules? 2 and 3. Answer. Yes, Dharneshwaran was also correct. Even null was correct, right? What is the relationship between 2 and 3? 2 and 3. Answer. Metamers. Null. No, bacha. That's what I taught you. That's what I taught you. Look at this molecule over here. This is carbon. This is there is no heteroatom. Metamerism is only shown around heteroatom. For example, oxygen is there, sulfur is there, nitrogen is there, and around these atoms, if the carbon chain number is changing, then metamerism. Here there is no heteroatom. Here the carbon is only present over here. Carbon is here. Carbon is here. So they will never show metamerism. There is no option. So what are they showing? Here the keto group has a 3rd position. Here the keto group is at the 2nd position. So what are they showing? Position isomer. Absolutely. Subodh is right. Ankit is right. Very good. Right. So these are position isomers. Position isomers. Absolutely. Now tell me what kind of isomerism is shown by 3 and 4. What kind of isomerism is shown by 3 and 4? Once again, very easy. 3 and 4. What kind of isomerism is shown? I've already discussed this in the last example as well. 3 and 4 are not position, bacha. Look at the position. Position of what is changing? Here in the 3rd, the keto group is at the 2nd position. Keto group is at the 2nd position. In the 4th molecule as well, the keto group is still at the 2nd position, right? So the position of the functional group is not changing. What is changing? That Ankit Singh has already answered. Absolutely chain. What is changing? See, here there is straight chain, here there is branched chain, right? So here they are showing actually chain isomerism. Absolutely beautiful answer. Now what kind of isomerism 2 and 4 are showing? 2 and 4. Answer. 2 and 4 are showing. 2 and 4. What kind of isomerism? 2 and 4 are showing. Position 2 and 4 are position. Absolutely, these are absolutely position isomers. Absolutely position isomers. Absolutely beautiful. Let's move on to the next question. Next is give various functional isomers of butane 1-amine and give their isomeric relations. This was asked in JEE Advanced. This is an old JEE Advanced question, right? So once again, old JEE Advanced have a tendency to get repeated. So that's why I'm teaching you, right? Again, another very beautiful question. Give various isomers of butane 1 amine, right? If you have any doubt, then I have also mentioned all the isomers of butane 1 amine. These are the isomers possible of butane 1 amine, right? Now, between all these, they have asked you give various functional isomers. So, I've already written down over here for you. And what I'm going to ask, this is an exercise for you. Now, what I've taught you already, like what is the relationship between 1 and 2, 1 and 3, 1 and 4, 1 and 5, right? And then 2 and 3, 2 and 4, 2 and 5. Do this exercise at home. You will definitely have fun with it. And if you want answers, you can once again join the Telegram group which I just mentioned and tell me if you are able to solve this, right? So this is an exercise for you. Will love doing this, and these kinds of questions are asked in actually JEE Advanced, right? I'm going to move on from here. The similar kind of stuff that I taught you will be applied over here, right? Now let's move on to the next kind, which is called Tautomerism. What is it called? Tautomerism. Absolutely, absolutely. Yes, this is absolutely subjective type. With lots of practice, you can definitely do it, right? Absolutely. And once again, I'm letting everyone know and letting everyone get it in their head that organic chemistry requires as much practice as your physical chemistry, right? Do not take it very lightly. Do not just read it like a comic book. Hai na? Ki there are so many pictures over here, just read it like a comic book. No. You will not score any marks till you actually draw things from your hand, till you actually circle them and see, oh, what is happening and what is not happening, because otherwise you'll get it wrong. That is for sure, right? There are so many mistakes, silly mistakes that you can do in your organic chemistry paper. Just do not do that. Chaliye, next kind of isomerism is actually tautomerism. Can everyone recall what all kind of isomerism we have already done? We have done functional group isomerism, we have done chain, we have done chain ring isomerism or ring chain isomerism, right? And we have done metamer. So we have done 4 kinds of isomerism. This is the 5th kind, which is called the tautomerism. In tautomerism, what happens? So there are various functional groups which show tautomerism, but the one main kind of tautomerism is shown by ketoenol. So we're going to learn tautomerism through ketoenol example and apply in various other functional groups. So what happens in ketoenol tautomerism? As the name is suggesting, there will be a keto group, which is a ketone group, and a enol molecule. En mean where the carbon which has the double bond, on that same carbon there is a ol, which is the alcohol group. This is called the ketoenol tautomerism. How it happens? So there is a condition. What is the condition for ketoenol tautomerism? That there should be a keto group, and to that keto group the carbon that is directly attached, whether here or here, it is called the alpha carbon. To that alpha carbon there must be presence of at least one alpha hydrogen. What should be present? At least one alpha hydrogen. Only then, only and only then it will show tautomerism. So what actually happens? I'm drawing it over here. This is your keto group. Remember one thing, and here it is your CH2 and I'm writing H over here. So what actually happens, just look over here, CH3, right? Both of these are alpha carbons, so I can call anyone alpha carbon. I can make anyone keep anyone in the spotlight for right now. Okay? So what is happening? Always remember one thing about your about your functional group. So whenever there is a multiple bond, any multiple bond, double bond, triple bond, whatever. So whenever there is a multiple bond in the functional group, that functional group will always behave as a electron withdrawing group. Very, very important. Very, very important characteristic I'm telling you. They will always behave, they will always take away electron from your carbon chain. So whenever this happens, the carbon next to it, which is called the alpha carbon, the hydrogen next to it becomes very, very acidic. It becomes what? Acidic. Why? Because the electrons are traveling in this direction, hence this hydrogen can be lost very easily. So this hydrogen becomes very, very acidic. Now what happens? This oxygen has lone pair on it, right? So this oxygen actually abstracts this hydrogen towards itself. Then what happens? After this oxygen, what will happen? This is C, this is O over here. This oxygen actually abstracted the hydrogen and kept it with it. Now this double bond will actually move over here. Now this carbon will actually get the double bond. So which carbon is getting the double bond? That carbon which lost its hydrogen and the carbon to which the O is attached, right? So this carbon will get the double bond and you will get what product? You will get the enol product, right? Understood this thing? What is happening? This is an electron withdrawing group, hence this hydrogen becomes acidic. Acidic means what? Anything which easily gives away H plus is acidic, right? Which the compound which very easily gives away H plus will be the more acidic compound, right? So hence this lone pair abstracts this hydrogen and forms an enol compound. Now remember one thing, enols are very unstable. These are very unstable. Why? Because whenever there is a double bond and on that double bond the OH molecule is never ever stable. Understand this thing. Whenever there is a double bond and a OH molecule, they are never stable together. Hence this is very unstable. The keto forms in maximum cases are the most stable form. Understand this thing. Keto forms are more stable than your enol forms. Is this thing clear to everyone? Okay? Ma'am, once the... Yes, bacha, I will definitely send the PDF. Do not worry about that. What about maths on this platform? Ankit is asking. Beta, maths teacher is going to join. This is a surprise for you. You are going to have the best maths teacher that you can ask for your JEE preparation. That is for sure. Right? And Ankit is asking, ma'am, once the reagents are changed above the arrows, I fail to process the reactions. Do not worry. I will... See, if I am here, right, if I am here for your JEE preparation, you can just definitely keep faith in me, keep all your trust in me. That is one thing that I can make sure that we are going to complete by this December. Okay? By this December, I am also going to bring you a list of all the reagents and how to solve the questions. So we're not going to do, see, I think most of the majority of the chapters are going to be taken up by Nabamita ma'am, right? So what are we going to do? What am I here for? I'm here to make your organic chemistry strong. And how do you do that? You do not do that by actually going line by line and doing that. What do I expect in this case? Now that we have led just 2 months, I expect that you are reading your NCERT, you are doing all the name reactions by your side. What am I here for? I'm here to make your life easier with organic. Whenever the reagent changes, what will happen? Exactly what question Ankit you have asked, right? Exact session I am actually preparing side by side because that needs a lot of time and a lot of research. What all kinds of reagents have been asked in your JEE mains and your earlier JEE advanced exams is actually taking time. Otherwise, that was supposed to be my very first lecture, but then I decided that students actually must know GOC and must learn GOC from my hand so that I know that I've taught you this. Do not forget that, right? If I'm your teacher and you are putting your trust in me, then I should be the one doing that, right? Next, hydrocarbon by you, absolutely. But after this, I'm going to take GOC class. I'm going to take which class? I'm going to take GOC part 3. This is the part 2. There is definitely going to be a part 3, right? Difference in position of hydrogen. I will tell you, bacha, alpha hydrogen, alkyl shows minus I effect due to electron withdrawing group. Beta, here that is not happening. And also alkyl group shows plus I effect, not carbonyl. If you are calling this alkyl, this is not alkyl. This group is actually called carbonyl group, right? Please get your terminologies correct. This is called carbonyl group. And these are showing minus I effect. Yes, they definitely show the minus I effect. Okay? Like aromatic compounds and if resonance happens. But ma'am, even, yes, bacha, Ankit, you are absolutely right. I'm going to come to that, right? Just give me some time. I'm going to come to that. Is this thing clear about keto-enol tautomerism? What is happening when the keto-enol tautomerism will be shown? When the keto form has at least one alpha hydrogen, then oxygen will abstract that alpha hydrogen and form the enol form. In majority, 90% of the cases, enol form is very less stable, right? Keto forms are mostly formed, they are more stable, that's what I've written. Next is, bacha, I have taken another example over here. Now what is happening? Look at this example. Here there is one electron withdrawing group over here. Can everyone see? The other group is a ester group over here. This is not a keto group, this is a ester group. Everyone can see the ester group. But once again, this ester group has a C double bond O group. So this is the electron withdrawing group, and here once again this is the electron withdrawing group, right? But where the keto-enol tautomerism will be shown, on which the keto form is there. So this is the keto form, this is the ester form, remember that, right? You will not form enol form on this oxygen, no, because this is the ester molecule over here. You can only form enol form on this molecule. Is this thing clear to everyone, right? Now bacha, what is happening? Now bacha, can you see this keto form over here? Here there is CH3 present, and here once again there is CH, and once again H is present, and here once again C double bond O, OC2H5 is present. Okay. Now bacha, what should be your next question? The first thing that I made clear is only this keto form will show the enol form. This will not show. Why? Because this is the ester molecule, not the keto molecule. The second thing is, ma'am, now there are two alpha carbons. This is also alpha carbon, this is also alpha carbon, right? But can you see that this center alpha carbon actually has two electron withdrawing groups attached to it. Hence, this hydrogen becomes most acidic. So, this hydrogen will become most acidic hydrogen, remember this thing. So, what will happen? The oxygen over here will abstract this hydrogen and form a enol form like this. Can everyone see? Now, this enol form is formed as 7.6%, which is very less amount, and the keto form, because it is more stable, it is formed as 92.4%. Is this thing clear? ठीक है? ठीक है? Understood? Understood everyone? ठीक है? अब बच्चा, in this example I have taught you that the enol form is less stable, keto form is more stable. But there are instances where the enol form is more stable. How? Can you see this molecule? Now, okay, look at this molecule. I've taken this cyclohexadiene, and there is a ketone group over here, right? Now, what is happening? Now, can you see there is an alpha hydrogen over here? So, when this oxygen actually abstracts this alpha hydrogen and this bond moves here, it is actually forming a more stable enol form. Why? Because it is actually forming a aromatic ring, right? Can everyone see? A benzene ring is getting formed, and a benzene ring is the most stable organic compound, isn't it? Hence, here, this is an exceptional case where the enol form is more stable, because when you are forming the enol form, the molecule is getting the aromatic character. So, what did I teach you? In tautomerism, keto forms are actually more stable. But in some cases, in some exceptions, if the enol form is getting stability through aromatization, then the enol form will be more stable. Is this thing clear? Chaliye, perfect? Chalo. Next example. Now, bacha, what I am teaching you once again is this molecule. Look at this molecule over here. What are these? This is the acetyl acetone. Now, I have taken two acetone molecules over here, right? There are two keto groups here. Now, what happens is only one of the hydrogen, actually what happens, this once again this hydrogen is getting abstracted and the enol form is getting formed over here. Can everyone see? Can everyone see from this keto form, I have formed the enol form over here. They are in dynamic equilibrium. Absolutely, they are in dynamic. Can you see? This dynamic equilibrium is going on over here. Okay. So, bacha, what is happening? Can everyone form the enol form from this? What will happen? This hydrogen will be abstracted by oxygen. This double bond will move over here and the enol form is formed. Now, look at this enol form. This is very, very important. This enol form, what happens? This hydrogen actually can form a hydrogen bonding with this oxygen over here. Can everyone see that? Now, due to the formation of this hydrogen bonding, once again, the enol form is more stable over here. 76% of the molecule is enolic. Only 24% of the keto form is formed. Why? Once again, due to the more stronger H bonding present in them. Now you will also argue कि ma'am, why are you forming only 1, 2, 3, 4, 5 member ring? We can actually form a very 1, 2, 3, 4, 5. We can actually form a more stable 6 member ring like this. 1, 2, 3, 4, 5, 6. Okay? You can argue that. Okay? That what can I do? I can make this hydrogen over here. I can form a 6 membered ring. But it doesn't happen. Why it doesn't happen? Because here hydrogen is very small. Is very tiny. So it is not, that molecule is too tiny to actually participate in ring formation. So what it will do, it will always be at the side of oxygen, and so that these two can join together and form a 5-membered ring. So this is not formed, only this is formed. So can you see, sometimes enolic form is more stable. When is it stable? Number 1, if the ring is getting an aromatic character. Number 2, if there is a formation of a hydrogen which is a much stronger bond, then it will definitely, in those cases, enolic form will be more stable and it will be more formed, right? Hyperconjugation, yes bacha, hyperconjugation we completed in the last class. Please do attend the last class, right? Hyperconjugation was completed in the GOC part 1. Attend that class, absolutely beautiful class once again. Understood? Does anyone have any doubt in this? Okay? Now, bacha, enol content is enhanced by what all factors actually increase the enol content? Okay, look at over here. Number first is acidity of alpha hydrogen of keto form, very important. Okay? The more acidic the hydrogen will be, more enol content will be formed. Okay? More acidic the alpha hydrogen, more enol content is formed. Second is intramolecular H bonding. What is intramolecular? Within the same molecule. Can everyone see? This H bonding is forming in the same molecule, right? Not between different molecules. In the same molecule, the H bonding is happening. Hence, if the intramolecular H bonding is happening, enol form is more stable. Next is resonance in enol form, as you've seen the aromatic ring, right? In the aromatic ring, what was happening? It was getting resonance stabilized, hence enol form was more stable. Or next is aromatization of enol form, that we have already seen, right? Understood? Is this thing clear to everyone? Understood everyone? Is this thing clear? Chaliye aage? Chaliye. Next is, the next question that is asked in your JEE Mains exam, have been asked, so you must definitely know. They also ask like, what kind of solvent actually increase the enol content? So remember one thing, I am once again showing you the enol form. Can everyone see this enol form? In enol form, in maximum times if enol form is happening, why is it forming enol form? Because there is formation of a hydrogen bonding within the same molecule. So, if the enol form is actually forming hydrogen bond within the same molecule, it cannot form hydrogen bond with the water or any polar solvent, right? Because it is already consuming its enol form to form H bonding within the same molecule. Understanding this thing? So what happens whenever you take a enol content? So enols are actually more soluble, or enols are actually more soluble in your where? यहाँ पे I am writing different solvents. Yes, in your organic solvents. So I am writing it over here. Enols are soluble in organic solvents. Very important. Okay? Enols are actually soluble in organic solvents. Why? Because it is unable to form H bonding with the polar solvents. You might think, ki ma'am, actually the alcohol. So I am going to again teach you one another thing which I have taught you in the previous class as well. What is that thing? For example, if I compare the polarity of the keto group as well as the polarity of the, the alcohol group, right? If I ask you just as it is, which is more soluble in water? Which of these is more soluble in water? What would be your answer? out of the ketone and the alcohol molecule. I'm writing this as A, I'm writing this as B. Answer me in the comment section. Answer me in the chat box. Which do you think is more soluble in water? Which do you think is more soluble in water? A? That is the wrong answer. That's what I'm teaching you over here. Your actually alcohol is more soluble in water. Why? Because alcohol has more potential to form the H bond, okay? Now if you cannot remember, ma'am, how can I remember that which one is more soluble, which one is more polar than bacha? In that case, just remember one thing. Whenever the molecule actually, for example, oxygen will definitely form the H bond, right? So whenever the molecule has an hydrogen already attached to it, that molecule will be more soluble in water. This is a general rule you will see anywhere and everywhere. Okay? So whenever a molecule has hydrogen attached to it, that will form a stronger hydrogen bond. This is the rule, right? Understood? So actually your alcohols are more soluble in water. But when you are comparing enols, so in enols what is happening, as I showed you, that intramolecular H bonding is forming, hence it is not getting any opportunity to form H bonding outside as you would expect. So in that case they are more soluble in organic solvents. Understood this thing? So these are more soluble in hexane, followed by benzene, then acetone, methanol. In water they are the least soluble. So as the polarity is increasing, the solubility is actually decreasing, right? So enol content increases in non-polar aprotic solvent, very very important. So enol content is formed in which kind of solvent more? So whenever you are taking a non-polar aprotic solvent, what is a non-polar solvent? Which has zero polarity in it. Polarity means zero charge separation. For example, if I write a HCl molecule over here and if I write a H2 molecule over here, right? So what is happening? In HCl, you have connected the hydrogen with the more electronegative chlorine, isn't it? So this has a negative charge, this has a delta positive charge. So I've connected it with a more electronegative chlorine, right? So in that case, what will happen? They will have a charge separation. It will become polar. So this is called a polar molecule. Why? Because there is a charge developing on both the atoms. But if you have connected two H2 molecules together, what will happen in that case? What will happen in that case? Both of these have equivalent electronegativity, so there is no charge separation. Hence, this is called a non-polar molecule because there is no charge separation, there is no dipole moment developing. This is non-polar. So you have understood the meaning of polar and non-polar. The other one is a aprotic solvent. Aprotic means what? Which cannot give proton. Proton means H plus, right? Which aprotic means no H plus is in them. So whenever a solvent has no H in it, then it is called a non-polar aprotic solvent. For example, look at it, hexane. Hexane cannot give its H molecule. Benzene cannot donate its hydrogen. Acetone can somewhat donate. Methanol can donate the hydrogen. And water can definitely, it is a polar protic solvent. Right? Understood? Okay? Does anyone have any doubt till now for polar aprotic, non-polar aprotic solvents? Okay? Now I am going to ask, is methanol, what kind of solvent is methanol? CH3OH. What kind of solvent is methanol? What kind of solvent is methanol? So can you see once again? Here this hydrogen can form a H bonding. Always understand this thing. Whenever there is a hydrogen attached to a electronegative atom like oxygen, nitrogen, then that solvent will definitely be polar because there is a presence of oxygen and carbon, it is polar, and it is protic because a hydrogen is attached to oxygen, right? So it is polar protic solvent. Is this thing clear? Methanol is actually polar and protic solvent. Similarly, if I talk about acetone, CH3 C double bond O CH3. What kind of solvent is acetone? So can you see there is polarity here? Why? Because the oxygen has delta negative charge, this has a delta positive charge, right? This is polar. So I have understood, ma'am, this is a polar solvent. But is it protic? Can it give hydrogen bonding? No, it cannot, because there is no hydrogen attached directly to the electronegative atom. Hence, this is polar aprotic solvent. Aprotic solvent. I hope this distinction is clear to everyone. Okay? Polar aprotic, absolutely, absolutely. Perfect, perfect. Is this distinction is clear to everyone? Perfect. Let us move on to the next question. Next is bacha. Now once again we are here to learn about tautomerism. Right? We are once again here to learn about tautomerism. So will this compound show tautomerism, benzaldehyde and benzophenone? Will they show tautomerism? Yes or no? Will they show tautomerism? Yes or no? I hope you are understanding whatever I am teaching. See, if you have any doubts, let me know, so that I can also improve my teaching skills and I can also give you the content that you are looking for. Is this the right content? Are you actually learning new things? Because I know if you are learning on YouTube, there must be some other place where you have already read these things, but you still can't make it clear in your head, right? That's why you have come on YouTube. Maximum bacha like that only is here. So what you can do is help me improve my content so that I can help you better. We are just a community of 1,000 people or 1,500, and out of those only very few are interested in academic lectures. Let me be very honest. Okay, that is why the competition is just between the top 2 lakh students, that is it, who participate in JEE Advanced. The rest of them are not even that interested. They'll just open their books just before the exam and that is it. Right? So if you are someone who wants to crack this exam and if you are in my community, you can definitely just let me know so that we can work on this together, right? This is once again my heartfelt request to everyone. No alpha hydrogen, absolutely. Both of them have no alpha hydrogen, so these will never show, not show tautomerism, not show tautomerism, right? Understood? No alpha hydrogen, no tautomerism. Perfect answer, perfect answer. Now, bacha, again, once again, what I'm going to tell you, tautomerism in the acid catalyzed as well as base catalyzed reaction. Why am I teaching you right now this? So, what happens in maximum of the cases? One second. Okay. So, bacha, what happens when we start doing the reactions, right? Then you come across all of these things, and once again you're bombarded with so much information, it is difficult to keep track on it. So when we are actually learning GOC, we are going to see how these factors actually will affect the things, the kind of products you're going to form in the reaction mechanism. So I'm going to teach you one thing. For example, I've taken a ketone over here. So I have taken we are first of all doing the acid catalyzed tautomerism. We have taken a ketone over here like this. Let us take this ketone, right? Now in acid catalyzed means what? I have taken this ketone in acidic medium. Okay? Now you will answer this question. I will not do anything. Your mind will keep track of each and everything and you will understand, ma'am, okay, now I understand what you're trying to do. So can you see? This carbon over here has a delta positive charge. Why? Because it is attached to more electronegative oxygen. So the oxygen has a delta negative charge. What is the next thing that will happen? This delta negative charge will definitely attack on this positive, isn't it? Because this is positive, this has a negative charge. So what will happen? Something like this would happen, something like this. Here C double bond OH will be made over here, right? And this double bond will definitely move over here and a double bond will be formed, right? So here what has happened? A enol form has been formed. A enol form has been formed. Does anyone has any doubt in this? Okay, a enol form has been formed over here, right? Easy. So this is the acid catalyzed mechanism. Now if I want to write a base catalyzed mechanism, how can I write that? Base means what? Once again I have taken a ketone over here, right? Now what will happen in presence of a base? OH minus. OH minus is a base. Now can once again everyone see what will happen? This carbon has a delta positive charge. Why? Because oxygen has a delta negative charge. So what will happen? This negative will now attack this positive carbon, isn't it? So what will happen next? This negative will attack this positive carbon. So what will happen next? We will get a structure something like this. This. Here is the O over here, and here this OH will attack, right? The OH will attack over here. Okay? Or the other thing that we can do, is, let's not do substitution reaction. Because what we have taken here is a base and we have not taken a nucleophile. What is the difference? I will let you know when we are studying nucleophiles and electrophiles and bases in those differences. Right? Here what I have taken is a base. What is the function of a base? It is to abstract hydrogen. Very, very important. Abstract hydrogen. The difference between a nucleophile and a base is just that. Nucleophile will itself get attached. The base will do what? It will abstract the hydrogen, right? So what is happening? Here hydrogen is there, here hydrogen is there, right? This hydrogen is acidic due to this carbonyl group over here. So what it will do? It will abstract this hydrogen, and what will be left behind? Like this, C double bond O, it will be here. And because the H plus is gone, so here a negative charge would be formed. Right? Now what will happen? This negative charge will flow over here and this will flow over here. I've already taught you this in your resonance class, isn't it? Because a negative followed by a single bond followed by a double bond definitely will show resonance. So what will happen? This double bond will be created over here. The oxygen will get a negative charge. Right? Now, in whatever solvent it is present, from that solvent it will abstract the H plus and it will form once again it will form a enol form like this. Okay? So in both acid and base catalyzed mechanism, you can show keto-enol tautomerism. Understood this thing? We have shown keto-enol tautomerism. Does anyone have any doubt? Now you got the difference between nucleophile and a base. I'm really happy that at least 2-3 students are learning from this class. This is making me really happy, right? Because I'm also working. See, if I'm taking a class, I've been taking a class since morning. Hai na? So now this is like, I've been working since morning and this is like my 4th class of the day. So I am also a little bit tired by now, but I want to deliver the best content for my students and I'm really happy that it's helping you guys. So if you start writing, yes ma'am, it's helping, it will also give me confidence and it will be like, okay, I'm helping some people. Otherwise it's like, I'm just building content for nobody. Hai na? This also takes time, efforts and everything. If you are getting content in a very crisp and precise manner, it means the teacher has worked really hard on that. Just remember that thing. Okay, because in no books you will find the content at just one place. It's just really difficult, especially for organic. Physical and inorganic are pretty easy, pretty chill. But I've taken the responsibility of the most difficult part, which is the organic, which is the most disorganized section. No matter what, everything will be applied everywhere, right? In one molecule, you'll see lots and lots of things happening. That's the beauty. I think that's the beauty of organic chemistry. Chaliye. We are ready to study. Thank you so much. Thank you so much. Chaliye. Next kind of tautomerism that we are studying. So in that tautomerism, what was the thing that you have to keep in mind? In keto-enol. In keto-enol, I taught you that there would be an atom to which a double bond is present. On that double bond, there is at least one more electronegative atom, right? And that double bond is actually making it a electron withdrawing group, right? That double bond is making it an electron withdrawing group. And what was happening? To that atom, there should be at least one alpha hydrogen present. Then keto-enol tautomerism would be shown. Now, this same principle is applied in the nitro-acid form of tautomerism. How? Look at this nitro structure. Can you see there is a nitrogen and a double bond O? Now, because a multiple bond is present, what did I teach you? That it will behave as an electron withdrawing group, right? This will behave as an electron withdrawing group. Then this hydrogen will become very, very acidic This hydrogen is becoming acidic, hence this oxygen will abstract this hydrogen and it will form what? This double bond will then travel here and it will form a acid form like this. Isn't it similar to keto-enol tautomerism? Same thing is happening. There has to be a double bond, and to that double bond there has to be a alpha hydrogen. Then that oxygen will abstract this alpha hydrogen and form a nitroacid form of tautomerism. Understood? Tautomerism is same. There is nothing different here. ठीक है? Pakka? Understood? Perfect. Let us move forward. Next. Okay. Now we have reached another beautiful example in front of you guys. I have taken 3 different molecules in front of you. Now I have asked you arrange these molecules in decreasing order of enol content. Once again a JEE Main question. Beautiful question, beautiful question. Try to answer this. Arrange the following in decreasing order of enol content. We have discussed all the possibilities where the enol content will be more, where the resonance is more, where the aromatization is more. If it is stabilized through hydrogen bonding, then more enol content will be formed, right? I've discussed all the possibilities of the enol content. Try to answer this question over here. So ma'am, base just abstracts hydrogen. Yes, bacha. Ankit, absolutely. Base, why is it called a base? Because it will abstract hydrogen, that is it. But nucleophile gets attached. Yes, but nucleophile gets attached. Absolutely. Base abstracts hydrogen, nucleophile gets attached, right? Both of them have a negative charge on them. Both of them are rich in, electrons. But what makes them separate then? That is a whole different topic that I will definitely take. But I've already, okay, once again, if you want to go through this topic now, and do you understand a little bit of Hindi, whoever is studying here? If you understand a little bit of Hindi, I've already made a video on that. Otherwise, I will definitely make a video in English on the same topic as well, because I know so many students have doubt on that, right? Chaliye, try to answer this thing and also answer how do we differentiate. Yes, bacha, that's what I'm saying. That's a whole different topic. It will take another half an hour. If I'm going to tell you how to differentiate between a base and nucleophile, let's not do this today. We're going to do it in some other lecture. But if you understand Hindi a little bit, I have a video already made on that. I will direct you to that video. Otherwise, I will make another one in English on this channel pretty soon. You know Hindi? Then okay, then check out the Rankplus NEET channel. Rankplus NEET channel, right? NEET. In that Rankplus NEET, I've made a video on, I guess, SN1, SN2, and in that SN1, SN2, I have made a differentiation between, I've actually taught you the difference between SN1, SN2, E1 and E2 mechanism. You will find it under the video section, right? Not under the live section, under the video section I've made a video. You can watch it. It's a beautiful video. Definitely watch it. Okay? Chalo. Let's do this question now. And if you still have doubt, you can definitely comment under that video. CBA, I've received the answer from null CBA. Okay. Does anyone has anything else to add in it? CBA, okay, let me see if you're correct or not. Chaliye. Decreasing order of enol content. So, bacha, how will the enol content be formed in A? Pehle A ka dekhe. Let's see for A. Here what is happening? There is a Me group. There, for example, here the hydrogen was there. The hydrogen got abstracted by this oxygen, and what it will be formed? It would form C. Here it would be O. Here it would be H. And here it would be double bond, here it would be once again C double bond O, here it would be Me, right? And here hydrogen bonding would be formed. Can everyone see? In the A molecule, there is a formation of H bonding. Can everyone see the H bond? So it will definitely contribute in the enol formation. So when I'm forming the enol molecule, it is forming the hydrogen bond. So it will definitely have a high enol content. Look at the B molecule. Once again, what will happen? The hydrogen from here will get abstracted, right? And what would be formed? Something like this would be formed. C OH, and here it would be double bond C, here it would be C double bond O, and here it would be this and this, right? And here once again what is formed? H bond is once again formed. Is this thing clear to everyone? Is this thing clear? H bond is once again formed in here. Okay? Now let us see the last molecule. In last molecule, can everyone see? If the hydrogen is abstracted from here, okay? Last molecule, just look at the last molecule. Now, if the hydrogen is abstracted from here, what is left behind? After the H plus is gone, what is left behind is a negative charge on it, right? And can you see what kind of molecules are attached over here? The methyl groups are attached, and methyl groups are what kind of groups? These are actually plus I groups. So I'm already negative and you've attached so many plus I groups on it. I'm already negative, you're giving me more electrons, so you're making me unstable. So this would be the most unstable species because the negative charge is not stable at all. So C would be the least. C would have the least enol content. I have already seen that. Okay, I already know that C will have the least enol content because for making the enol content, I need a negative charge, and that negative charge is least stable over here. Now I have to compare between A and B. Ma'am, in both A and B, what is happening? In both A and B, they are actually forming the hydrogen bonding. Then how to actually differentiate? Then bacha, the best thing to differentiate is what? Do you know what kind of alkenes are more stable? What kind of alkenes are more stable? More substituted alkenes, isn't it? More substituted alkenes are more stable, right? More substituted alkenes are more stable. Hence, which of these is more substituted alkene? Can you see B is the most substituted because there are more groups over here, more groups over here, more the groups, more substituted is the alkene and it is more stable. Hence, B is the most stable, followed by A, followed by C. So, this is the correct answer. BAC. BAC is the correct answer. Is this thing clear? BAC, absolutely perfect answer, Dharneshwaran. Got it? Got it? More alpha hydrogen alkenes are stable. Absolutely beautiful answer, Ankit. More alpha hydrogen alkenes are more stable, and this has more alpha hydrogen, isn't it? This has more, yeah, when you talk like that, this actually doesn't have more alpha hydrogen, but this is a more substituted alkene, right? Okay. Got it? Got it? Let us move forward. Let us move forward. Next is write more stable tautomerism structure of the following. Once again, you have a JEE Main question over here. So what they have asked you is to write the more stable. So whenever I am writing JEE Main question, it doesn't mean that it has been asked in the similar way. They've asked in form of MCQs obviously, but you must know what kind of molecules they have given in the MCQs. So what I have done over here is I've compiled all the questions and I've compiled them into categories. Like for the phenol, they've asked which will show the more enol form, right? And for the methyl 3-oxobutanoate, which will form the more keto form or the enol form, right? For example, what do they actually mean by the phenol, right? Whenever I'm making a phenol molecule, how am I making it? I'm making it like this. And I already know that phenol is more stable. Why? Because it has the aromatization character in it. More aromatic the compound, more stable it is. So, enol form is more stable than whatever is its keto counterpart. What is the keto counterpart? Keto counterpart which somewhat look like this. This is the keto counterpart. So, the enol form is more stable in the A. I already know that. This is the A option. Let us now write down the B option. B option is what? Methyl 3-oxybutanoate. Let's form this. Oxy, so first they have written methyl, which means to the O methyl group is attached. So that's why you should definitely know the IUPAC naming. How to write the structure from the name. Methyl means methyl is attached directly to the oxygen and then it is 3-oxobutanoate. How will you write 3-oxobutanoate? 3-oxobutanoate. So it's like C and then once again. Okay, how will you write this structure? Tell me. 3-oxobutanoate, 1 second. Okay, so you will form it like this, 1 second. This is butanoate 1, 2, 3 and 4 and this is butanoate and here it will be 3-oxo. So at the third position there is a oxo bond over here, right? This is 1, 2, 3. Here it would be again oxo. So how I've written this? Okay, look at over here. Once again, this is the first carbon, second carbon, third carbon, fourth carbon. Why is it the first carbon? Because this is where the ester functional group is there. So wherever the functional group is there, that is considered the first carbon. So it would be methyl 3, or the third position there is oxo group. Oxo means keto group. So 3-oxobutanoate. Why is the oxo group keto group? Because here the keto group is not the main functional group. So it will be treated as the substituent. And whenever we treat substituent, whenever we treat keto as a substituent, we write oxo in its position. So this is the final, this is the final name to it. Okay. Now what they've asked you to form its keto form. So let's form the keto form of this. How will you form the keto form? This is the carbonyl atom over here. This is once again carbonyl atom over here. But this is the keto group. Only with the keto group you can form the enol form. So what will happen? The hydrogen over here will be abstracted by this oxygen, right? And what will happen is you will get something like this, OCH3, and here it would be C, double bond O, here it would be C, double bond C, double OH, and here it would be C. Now once again, this OH over here, what will this OH do? This OH once again will form the hydrogen bonding, isn't it? This OH will once again form the H bonding. So here in the second molecule, once again H bonding is forming. So the enol form is more stable. Enol form is more stable. Why? Because the hydrogen bond is forming. That's what I taught you, right? Whenever the hydrogen bond is forming, the enol form is more stable. Okay? Beta, here you do not have to compare between these three. You have to tell me what will happen in the first example, what will happen in the second, what will happen in the third. So in the first, once again, enol form is stable. In the second also, enol form is more stable. Let us look at the third example. Okay, now from the third example is really, really easy. Once again, very easy. And this example was asked in JEE Mains 2023. I remember this question. This is a very good example. You know, they asked it in the, this is once again, okay, first draw this molecule, then I will teach you that how did they ask about this molecule. What was the question asked? What was the exact question asked, right? So, is this thing clear? Can I rub this? Is this thing clear? I've rubbed this. Now, let us focus on the C molecule. They have given you cyclohexane 1,3,5 trione. So, I have formed cyclohexane. At the first position, there is ketone. At the third position, there is ketone. At the fifth position, there is ketone. Right? Now, what they have asked you, they've asked you whether the keto form is stable or the enol form is stable. Now, try to draw the enol form of it. How will you draw the enol form? Here, can you see there is alpha hydrogen, there is alpha hydrogen, there is alpha hydrogen, right? So, all these three alpha hydrogens will be abstracted by these, oxygen atoms. And what will happen then? A structure something like this would be formed, something like this, OH, OH and OH. So, can you once again see what is happening? When I have formed the enol form of this, it is once again aromatic. So, enol form will become more stable form, isn't it? Enol form will be more stable form. Is this thing clear? Is this thing clear? Clear? Yes? ठीक है? So we're going to use these things once again when I'm teaching you aromaticity. We're going to do so many examples which have been asked in JEE Mains, and you're going to see the same example over there, because once again it has become aromatic, right? So there they have asked it in the form of aromatic molecule, like which one would be more stable in that sense, right? Is this thing clear? Now once again, this is a very good example. I want you to try this also. See, they have given you the molecular formula of diphenyl methyl. They have written over here, this is diphenyl methane. Now they've asked you how many structural isomers are possible when one of the hydrogen is replaced by a chlorine atom. So what they've asked you is how many structural isomers are possible when you replace one hydrogen one by one, okay, by one chlorine. How many isomers are possible? Just use your brain. It's not very tricky. It's a very easy question. It's a very easy question. Try to answer this. Yes, aromaticity developed. Absolutely. Absolutely. Try to answer this. Try to answer this. B4. Beautiful answer, Nal. Beautiful answer. So what will happen over here? So what can happen? I can either replace this hydrogen with chlorine, right? So this would be one isomer. What other thing I can do? I can replace all the ortho positions with the chlorine atom. So this would be the second isomer. Or I can replace all the meta positions with chlorine. So it will be third isomer. The fourth kind is where I replace the para position with chlorine. It would be the fourth isomer. So the correct answer is 4. I hope you got the question, right? I hope you understood what I'm trying to tell you. Okay? Understood? Ankit Singh, 4. Absolutely beautiful answer. Beautiful answer. Now we have entered into the territory of stereoisomerism. We have completed structural isomerism. I hope all the things are clear with you. I have explained in utmost detail that is possible with examples asked in JEE. I don't think such content, crisp content is available anywhere no matter what you do. Okay, because I actually, okay, just let it be. So we have done almost all the things that are required for your structural isomerism questions. Now we have entered into the stereoisomer. Stereo means what? Stereo means the connectivity will remain the same. In structural, we show that the connectivity of atom was changing. Sometimes it was connected to just one oxygen, sometimes it was connected to 2 carbons, like that, right? Like how I taught you about the structural isomerism between alcohol and a ether. So those are structure. In the structure, there is difference. But in stereo, what you will see, the structure will remain the same. The atoms connected to the carbons will remain the same, only their spatial positions will be different. For example, I've drawn this alkene over here, right? I've drawn this alkene over here. This alkene molecule has a CH3 over here, a hydrogen over here, a hydrogen over here, and a CH3 over here. So what is happening? I've drawn another molecule like this alkene. Here the CH3 is here. Once again the CH3 is here. Here the hydrogen is here, here the hydrogen is here, right? So I've drawn these 2 molecules. Now are these isomers of each other? Absolutely. But what kind? These are stereoisomers. Remember one thing, whenever there is a single bond is there, the molecules can rotate around the single bonds, right? But whenever a multiple bond is there, like a double bond or a triple bond, then the rotation is fixed. They cannot rotate. Wherever the molecule is present, they will be present there. They cannot be rotated. So this molecule is different from this molecule because you cannot rotate and change it into that molecule. Understood? The rotation is not allowed. So this is different, this is different. So when the similar groups are present at 180 degree to each other, opposite ends, these are called trans isomers, right? And when the similar groups are at the same position, at the same side of the double bond, these are called cis isomers. Is this in clear? These are called cis isomers, right? Okay? Yes, restricted rotation. Correct. Okay. Now what is happening? Is this in clear? Trans, and this is cis isomer. The next thing that we're going to talk about is these are called geometrical isomers. In stereoisomers are of 3 types. One is geometrical, one is optical, one is conformational. We're going to go through them one by one. First of all, we're going to talk about geometrical isomerism. Understood? Now let us understand. Before that, there is a question PYQ once again from your JEE class. Answer this. Which of the following pairs represent stereoisomerism? What? Which of the following pairs represent stereoisomerism? Answer this question. Which of the following pairs represent stereoisomerism? B. Optical and geometrical, absolutely. Optical and geometrical are stereoisomers. Even conformational is a stereoisomer. Absolutely beautiful answer. Chaliye. Next is, so before we enter into stereoisomerism, I want you to know that these are all structural isomerism. Why? Because these structures are different. This is a ring. This is, here the double bond is at the first position. Here the double bond second position. Here they have branched it. Here if they formed a ring as well as branches, right? So here the structure is changing. Hence all of these are actually showing structural isomerism, different kinds. Some will be functional groups, some will be position, some will be ring chain. Different kinds of structural isomerism are shown here. So these are also called constitutional isomers. You can either call them structural or constitutional. It's one and the same thing. Now let us enter into the stereoisomerism. Before that, I once again mentioned you in the slide that the rotation is restricted around the double bond. You cannot change, you cannot rotate the molecule, hence the position of the atom is fixed. But it is not the case in the single bonded atoms. Hence, they form conformers. Here, they do not form conformers, right? Next is, this is the same thing I've mentioned over here. And once again, as I've told you, ki these are showing what kind of isomerism? These are actually showing conformers, right? For example, this is a single bond over here. You can rotate on this single bond and this can get converted into this. So this is called the syn position, this is called the anti position. But once again, you can rotate the anti position and get the syn position, doesn't matter. So these are actually called conformers and these are actually the same molecules, identical molecules. These are not different molecules. These are interchangeable through rotation and they also have same physical properties because they are the same molecules. But if we introduce a multiple bond in it, then this molecule cis1 and the transfer are not the same molecules. Understand? You cannot rotate this molecule into this molecule. Rotation is prohibited. Same thing is mentioned. These are geometrical isomers. These are isomers. These are conformers. Both are different things. Okay? These are different molecules. They cannot be interconverted to each other through rotation. They have different physical properties. Very, very important. Because these are separate molecules, so they have different physical properties. Will you do electron migration effect? Beta, I've already done electron migration effect. Watch the GOC part 1. It is available on this channel. I've done it previously. Watch it. I've done all the electronic effects, right? Distance between two atoms changes. It shows geometrical isomerism. Correct, Ankit. Correct. Now, let us move on to the geometrical. For example, I've written this molecule. Now, this molecule, I can write it either in its cis form. Cis means what? Cis means two similar atoms are at the same side of the double bond. So, this is a cis3 hexene, or I can write it as a trans hexene, right? Where the similar atoms are at the opposite ends. Simple. So, this is the geometrical isomerism of cis and trans. Now, let us understand few properties of cis and trans. For example, if I have written a molecule, let us write a molecule over here. For example, here C double bond C is there. Here I have written chlorine. Here I have once again written chlorine. Once again I have drawn a double bond Cl and here I have once again added Cl over here. Right? Now, bacha, what will happen? Let us add hydrogen here, hydrogen here, hydrogen here. As you can see, this is a trans molecule. This is a cis molecule. In trans molecule, what happens? The trans molecule chlorine is more electronegative, so it will attract electron towards itself. Here again, chlorine is more electronegative, it will attract electrons to itself, right? So what will be the dipole moment of here? Dipole means what? What is the polarity? Dipole means one is attracting electrons here, one is attracting electrons here. So what will be the resultant? The resultant will be 0. So what happens in maximum trans molecules? That there is no dipole moment, which means these are actually non-polar molecules, right? No dipole moment means what? These are non-polar molecules. But if you look at cis molecules, what is happening? The chlorine is attracting electrons towards itself. Once again, chlorine is attracting electrons towards itself. So what will happen? The electrons will be pulled in this direction, isn't it? This direction it will be pulled. So what will happen now? So here it has some dipole moment which is greater than 0. So therefore your cis alkene is actually a polar compound. Can everyone see that? Cis is polar, it has a more dipole moment. Understand this. Okay, now we are just comparing the properties of cis and trans. Okay, let us move on to the next thing. Ab bacha cis and trans, if you are talking about cis and trans, also understand, for example, this is a benzene ring over here. So here in the benzene ring, so okay, one more thing, that here what I am about to tell you is trans is more stable. If you are talking about stability, then trans is more stable than the cis compound. Why is that? Because the similar group are on the opposite side, so there is minimum repulsion. Due to that, in maximum cases, trans is more stable than your cis geometrical isomer. Understand this thing. But when you are talking about a ring like this, can you see this ring? In this ring, what is happening? The cis isomer, this is the cis isomer, right? And if I form the trans isomer of this, what will happen? This is first carbon, second carbon, third, fourth, fifth, sixth. So when I am forming a trans ring, can you see there is a lot of ring strain in it? I have just twisted the ring and I have caused a lot of ring strain in it, which means this is much more unstable. So if you are comparing cis and trans isomer of rings, then in rings the cis isomer is actually more stable. This is more stable. Is this thing clear? Is this thing clear? In ring this is cis is more stable, but in chains trans isomer is more stable, right? Chaliye. Next is, okay, now bacha, all of these molecules actually show your cis and trans isomerism. For example, this is a double bond over here. Can everyone see a double bond? On this double bond, there are groups attached A, B, A, B. So what is the first criteria for cis and trans isomerism? That one carbon, matlab both of these carbons should have different groups attached to it. If they have same groups, then they will not show cis trans isomerism. What do I mean by that? For example, I have made an alkene like this, and to this group I have attached CH3. To the same group I have attached CH3, and here I have attached fluorine, chlorine, no matter what. Now, how can you tell which one is cis, which one is trans, right? Because to the same carbon you have attached same groups. So this cannot show cis or trans or geometrical isomerism. This will not show geometrical isomerism. So what is needed? That to one carbon there should be at least two different groups present. Then it will show cis, trans or geometrical isomerism. Similarly, look at over here. Here once again a double bond is there, a carbon is there, two different groups are there. But to this double bond, can you see a lone pair is attached as well as a OH group is attached. This will also show your geometrical isomerism. A lone pair and a OH group will show. Similarly here, once again an atom is there, a double bond is there, a lone pair is there, a lone pair is there, and an atom is there. This will also show geometrical isomerism. So even if a lone pair is present instead of an atom, that will also show geometrical isomerism. Understood? Similarly, this ring will also show geometrical cis-trans isomerism. Why? Because the rotation around the ring is prohibited. As I told you, the ring is fixed. The ring, I cannot rotate the bonds in the ring, right? In the ring, I cannot rotate the bonds. Hence, what will happen? If the molecules are at the same position, it is cis. If the molecules are at the opposite end, then it would be trans. Simple. Similarly, for the rings greater than 7 member, this will once again show your cis-trans isomerism. This will also show your geometrical isomerism. Once again, look at over here. There is a double bond over here. To this double bond, what has happened? This is a very, very good example. Look at this carbon over here. It has two different groups attached, A and B. This can show geometrical isomerism. Now look at this carbon over here. This carbon has this group over here. This carbon has this group over here, right? So can you see that there is a dissimilarity happening due to this CH3 present? So this will definitely show geometrical isomerism. But if instead of this I have drawn a structure like this, if I drew a structure like this, for example, like this. Now will this show geometrical isomerism? Will this show geometrical isomerism, yes or no? I mean double bond in less than 8 member ring don't show geometrical isomerism. Beta, it will show. Look at over here. This will definitely show geometrical isomerism. Okay. And here ring greater than 7 members can form a double bond like this, and this will once again show your geometrical isomerism. Right? I think, see, rings even smaller than 7 or 8 members, those are just cycloalkanes. And these are cycloalkenes. So we are comparing two different things. This will this will not show geometrical isomerism. Why? Because can everyone see to this carbon a similar group is attached over here and a similar group is attached over here, no matter from where you start. And hence this will not show, because if both of the atoms are similar, if both the bonds are attached to similar atoms and there is no point of differentiation, then it will not show your geometrical isomerism, because there has to be something to compare it against to, right? ठीक है? चलिए, next, beautiful. For example, for the larger rings, what I have written over here, understand. For the larger rings, what have I written? For example, this is a large ring, ठीक है? And here, the larger rings we can signify as whether is it a cis ring or is it a trans ring. What do I mean by that? For example, when the double bond is over here and both the CH3 groups are at the cis position. Can everyone see this is cis position? Why? Because the CH3 groups are at the same side of the double bond, right? So this is a cis cyclodecene. But if I write you are actually talking about the trans, how will you form the trans cyclodecene? You will form it like this. For example, a double bond is here, one methyl group will be here, the other methyl group will be here. So this will form the trans cyclodecene. Understood? Understood? ठीक है? Yes, because same group from both sides. Understood? Chaliye. Let's move on to the next thing. Now let us compare the cis and the trans forms of the alkenes. So what did I tell you? Trans form is generally more stable. One word I am using everywhere, generally. There will be exceptions everywhere. This is chemistry. It is filled with exceptions. But generally, if they are asking you a generalized question, then you will write yes, trans form is more stable. Dipole moment. Cis has the more dipole moment. Yes. Next is boiling point. Which one will have a higher boiling point? Understand. Boiling point is dependent upon your polarity. Very, very important. More polar is the molecule, more will be the boiling point. So among these, cis is more polar. So hence cis will have the more boiling point. Melting point, always understand, melting point is only and only dependent upon one thing, which is the crystal lattice. More symmetrical is the crystal lattice, more will be the melting point. And always remember, trans, no matter which trans you're talking about, trans alkene, trans benzenes, whatever trans you're talking about, those trans species are always more symmetric when you arrange them in a crystal lattice. Hence, trans form will always have a higher melting point. Very, very important. Polarity, obviously cis is more polar, as I told you, because it has a more dipole moment. Solubility in water, if I am asking which will be more soluble in water, water is polar. Hence, in polar solvents, polar things will dissolve. So the cis will be more soluble in polar solvent. Understood? Then cis form can be more soluble. Yes, absolutely, Ankit. If H bonding is possible in cis form, then it would be more soluble, more stable. Absolutely, absolutely. Yes, there will be exceptions everywhere, because this is indeed chemistry. Let us move on to the next thing. Another thing that is asked in so many exams is a question like this, right? So you should definitely read it under the geometrical isomerism questions. So what is present here? Here I have mentioned a cis malic acid. Can everyone see? The similar group are on the same side of the double bond, and here I have taken a transfumaric acid. Can everyone see? The COH are on the opposite side of the double bond. So this is a trans, this is a cis molecule. When you are heating the cis molecule, what will happen? When you are heating the cis molecule, H2O will go away like this. And H2O will go away, and what will be formed? If I remove the H2O, the entire molecule till C double bond C will remain as it is. And what will happen? This will get the C double bond OO, this kind of anhydride will be formed. What is formed? This kind of anhydride. Is this thing clear? When the cis form is heated, an H2O molecule is released and an anhydride form is formed like this. But what happens when you heat the trans form? Then bacha, what will happen? A very interesting thing happens. Can you see that now only 2 carbons are remaining? Only 2 carbons are remaining, and they are forming a anhydride like this. So it is forming a anhydride like this. Okay, only 2 carbons are remaining in this case. So this kind of anhydride is formed, very, very important. Okay, so both will give different products. Both will give rise to different products. Shall I move on to the next question? Okay. Next is geometrical isomerism in cyclic compounds. Once again, very, very important. Look at the geometrical isomerism in cyclic compounds. What is happening? I have taken a cis form of a cycloalkane over here, right? I have taken a cis form of a cycloalkane. Can everyone see Cl is on the same side? Cis form. Here it is a trans form. Here once again COH is on the same side, cis form. Here COH is on the opposite side. It's a trans form. Is this thing clear? Is this thing clear? Right? And once again, I can form it in another way as well. For example, if I ask you something like this. Here, right? So what is happening over here? Can you see? The 2 CH3 groups are coming out, right? This, what does wedge sign represent? Wedge sign represents that the CH3 group is actually coming out. So this is actually showing you the cis form, and this is actually showing you the trans form of the cyclohexane. As I told you, that cis and trans will be shown by the rings, right? Because the rings cannot rotate. So if the CH3 is coming out, the other CH3 is going back, it will remain in the same position, because this is a ring and not a chain. Understood this thing? So this is a cis form, this is a trans form, right? So let me ask you another question. For example, I have written something like this. So which is the cis form and which is the trans form over here? Which is the cis form, which is the trans form? We just discussed it. So let me name it as A, let me name this as B. Which is the cis form and which one is the trans form? Which one is the cis form and which one is the trans form? So can you see here? The similar CH3 groups are actually at the opposite end of the double bond. So this is actually the trans form, right? So here one hydrogen will be here, the other hydrogen will be here, right? And if you look at over here, here both the CH3 are on the same side of the double bond. So this is actually the cis form. So we already did something similar to this, right? And once again, I want to ask you another very beautiful question. Let me make it over here. Let me make it, oh, not like this, 1 second. Okay, and I'm drawing another ring like this. Here is the hydrogen, and here once again is the hydrogen present. So tell me over here which is the cis form and which one is the trans. Is this cis or is this trans? These two rings, is it cis or is it trans? So can you see over here? Here the hydrogen is coming over here and the other hydrogen is coming over here, right? Or you can see that one CH3 is coming over here, the other CH3 is going over here. So this is actually the trans form, right? So they can already ask you, they can just give you the rings and they can ask you, is it a cis ring, is it a trans ring? Then you should definitely know which one is a cis ring and which one is a trans ring, right? Is this thing clear? Why is this a trans ring? Why? Because one CH3 is coming over here and the other is coming over here. So this is definitely a trans ring, right? Understood? 10 minutes break, bacha. Let's not take 10 minutes break. Let's just cover it. Let's just leave it over here because let me see what else is there. Okay, let's do this last question and let's continue in our next lecture. Okay, we've already done like 2.5 hours, I guess, right, for today. Look at this question. Arrange the following ligands in the decreasing order of priority. Okay, I've not taught you priority yet, so you'll not be able to do this. So priority we actually see in the EZ nomenclature. So we'll do this in the next class. So we'll start from the EZ. So next class is probably going to be a longer one because we have to do EZ, we have to do RS, we have to do aromaticity. So we'll try to complete in the GOC part 3, right? Ma'am, cover entire GI today. But I'm also already tired a little bit, I'm really sorry. But we'll cover it in the next class. Do not worry, right? I'll cover the entire geometrical isomerism in the next class because we also have to do the EZ nomenclature. It will definitely take time. Okay? Chaliye. Because I've already attached the questions, but I'm going to give you the questions in the next class. I'm not going to open the questions for you. I prepared the lecture for like a whole 3-hour session, but my energy is not up to the mark today. Thank you. Is it okay if we do it in the next class? Is it okay? ठीक है? Chaliye. Thank you so much. And if you want to know the class schedule, then it will be posted on the channel. I will try to be more frequent on this channel. We will try to do many questions, many examples so that none of the questions are new for you in the JEE Mains 2025 attempt. Once again, a very interesting news is coming. See, so what was happening till yesterday? Till yesterday, there was a video floating that said that very minimum registrations of the entire history has happened till now for the January attempt exam, isn't it? So this news was floating everywhere, but right now if you check, maximum registrations for the entire history of your like JEE Mains exam, maximum registrations have happened for the 2025 January attempt. Actually, they've crossed like the 12.5 mark. I think we already have 13 lakh registrations. And these registrations will actually only increase in the April attempt. Remember this thing. So what has happened, bacha? Actually, your syllabus has reduced. So this has given even the NEET students chance to prepare for both biology and mathematics together. So now your competition has increased because the syllabus has reduced. So people are actually very prepared to excel in both the fields. And students who actually take up both, who actually have the jigra to take both maths as well as biology, they're actually pretty smart in the head, right? So the competition is going to be even more in the April attempt. I do not want to scare you. This is going to be the attempt which you have to give your 100% in it. Expect around 16 lakh registrations in your April attempt. This is for sure because right now we're seeing like 13 lakh. I don't know how many registrations are going on. Okay. Ma'am, by when will our syllabus be completed? But I cannot talk about, for maths, soon your classes are going to start. So just expect for mathematics that it's going to take another 1.5 months to complete. While for the chemistry, I can, probably for the organic chemistry, I can promise that by December we are going to complete it. Not before that because we've already started a bit late, right? So before December or by December end, definitely I'm going to make you complete the entire syllabus, and then we're going to just do question practice for the entire month of January till your exam is there on January 22. Right? No worries. You're not scared. Perfect, perfect. Chaliye. Thank you so much for attending this session and I will see you in the next video. Bye-bye.